All right, in today's lesson, we're going to do just the reverse of what we did yesterday. So we're going to use our product rule, the quotient rule, and the power rule that we used yesterday, but today we're going to be given the expanded version, and our job is to condense it down to one logarithm. So you'll have multiple logarithms in the original, and your job is to write it as one logarithm. So let's kind of review this. So let's say they gave me a problem that looked like this. The log base 4 of x plus the log base 4 of y. Remember, the product rule says I can write them as the same base, since they have the same base, and I multiply the x and the y, and that would be my answer. Quotient rule, we subtract because it's dividing. So, as an example, if I say the log base 2 of 7 minus the log base 2 of 3, I can condense that to one logarithm of base 2, and now it's just 7 over 3, and that's my quotient rule. The power rule says I can take that power, the coefficient in the front becomes a power. So if I have 3 times the log base 7 of x, all I have to do is move that to the power. So it becomes the log base 7 of x to the third. All right? Now let's write these as a single logarithm. Look at these examples. All right. We have coefficient out front here. That means it's going to become a power. And we have a minus sign, so that means we're going to be doing some dividing. But what we have to make sure of is that these logarithms have the same base, and they do. So I'm going to write it as the log base 5. Now let's look at the first term. Of 4 squared. Minus sign means over, and then what is it? Over 10. So I don't stop there because I can keep solving this. Log base 5 of 4 squared, that's 16 over 10, and I can reduce that fraction. You should always reduce the fraction. Log base 5 of 8 over 5. There's my answer. All right, so it's important that you look at whatever connects the logarithms. That will help you know the placement of the following term. Okay, if it's a minus, it's gonna be underneath the division bar. If it's a plus, we're multiplying. All right, so let's try number 2. Let's look at this for a second. We have a base of a minus, 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 right? So I'm gonna start with my single base, log base a of 48, and then I have to put a division bar. And let's put in what we know. We have 2, remember this becomes a power, cubed times, and this would be a 5. Now, let's clean that up a little bit. Log base a of 48. 2 cubed is 8 times 5. Log base a of 48 over 40. We can reduce that. Log base a, let's divide that by 8. Can we divide both by 8? Yep. That would give me 6 over 5. And this would be the most reduced condensed form of the equation. All right, look at number 3. Log base 2, that's the shared logarithm. So we're going to start with the log base 2. Now there's a coefficient out here, so that becomes a power. So x to the 10th. The minus tells me there's a division bar. That coefficient goes with this x back here, so it'd be x to the 12th. Now, I can clean this up. Remember our exponent rules. Log base 2. So remember our exponent rules. There's 12 x's on the bottom, there's 10 on top. So if I cancel all out, I'm left with none left on the top, but I still have to have a numerator, so I put a 1 there for a placeholder. And then I would be left with 2 left on the bottom. So this would be the reduced condensed form of my equation. Look at number 4. 6 natural log of x to the 3rd plus 2/3 natural log of x to the 6th. All right, we got lots going on. So let's move our power. So we're going to be raising a power to a power. So let's write that. So natural log of x to the 3rd raised to the 6th power. Plus means times, so it's product. So it'd be x to the 6th to the 2/3 power. All right? Now, if we remember our exponent rules, power raised to a power, we multiply. So I'm going to have the natural log of x to the 18th times, now what happens here? Put that 6 over 1 and look at it. If I multiply across, I'll have 12 over 3, which reduces to 4. So it'll be x to the 4th. Then we can combine these two if they're side by side and the bases match. Remember, we add the exponents, so we'll have x to the 22nd power. Natural log of x to the 22nd power. So this is 1/2 log base a of 4. So remember, this 1/2 is going to become an exponent. So it's going to be log base a of 4 to the 1/2 power. Well, that is log base a of the square root of 4, right? We can clean that up. That becomes the log base a of 2. And this is how I finish the question. So if you can reduce the numbers, you should always reduce the numbers. Number 6. All right. So we have a plus sign and we have a minus. So that means we are going to have one log because we're condensing, but we are going to have a division in here, okay? And this part's going to go underneath. So let's break this up. We have 6 squared times 3 to the 1/2 power, all right, over 12. All right, let's see what we can do with that. That is going to be the log of base a of 36 times the square root of 3 over 12. Now, I can reduce, right? That 36, I can divide that 36 by 12 and end up with just a 3, right? So that reduces nicely, and I end up with the log base a of 3 square roots of 3. That is the simplified version of it. Number 7. All right, let's move our powers over where they need to go. So log base 4, it has a minus sign, so I know it's going to have a division bar. So I'm going to have 16 to the 1/4 power over 27 to the 2/3 power. All right, now, that means the log base 4 of the 4th root of 16 divided by the cube root of 27 squared. All right, that's a hot mess, right? Now, before I go further, I want to think through this, okay? This is the 4th root of 16, so let's break it down 16. That is 2 times 2 times 2 times 2. So that means a 2 is going to pop out for me in the numerator. So I'll have a 2 over, what about the bottom? That's a cube root of 27 squared, so 2 27s, right? Well, 27 is 3 times 3 times 3. There's 2 of them, so I do 3 times 3 times 3. That means I can pop out 2 2s. That'll be a 3 times 3 that come out, and they will come out as a 9. Multiply them together, and I get my 9. So, again, make sure you reduce. Reduce, reduce, reduce. All right, let me know what questions you have when you get to class. Thank you for listening carefully and taking notes.